actually have to use our catch-up day this week. There's a catch-up day on the calendar for next week, but 1.3 takes so long to get through that I ought to just go ahead and allow it 3 days. We didn't get as far as we wanted yesterday, but we're going to go however far we can today, and then I'll tell you where to stop in homework. Where we left off, we had simplified, multiplied, and divided rational expressions. We had added and subtracted rational expressions. We were right here to simplifying complex rational expressions. And if I only get to do one example in class, I want you to remember that the whole reason that I typed these page numbers on here is if that one example is not enough for you, you can look on page 36 and there's another example. What does complex fraction mean? How do you look at something and go, oh, that's a complex fraction? Fraction within a fraction. And no self-respecting math person is going to leave that ugly sucker as the answer. You don't leave a complex fraction as an answer. So there are 2 ways we simplify a complex fraction. I'm going to show you the way that I like. It seems simplest to me, and it's helpful to do it this way in college algebra. But if you like the other method better, it's okay. It's not about how you do it. It's about getting the right answer. So let me see which method the book used. The book actually used not my favorite method. They got a common denominator for these 2 fractions and combined them into a single fraction. Once you have a single fraction divided by something, it's just a division problem. You take that single fraction and multiply it by the reciprocal of the denominator. So getting a common denominator and adding these 2 fractions is absolutely one perfectly fine way to simplify a complex fraction. What I prefer is to multiply every term by the LCD. The LCD here would be x plus 3 times a plus 3. I multiply all 1, 2, and the denominator by the LCD to cancel out the baby fractions, and I end up with the same thing. Actually, even though it takes a minute, I think it's worth showing you that way. Page 36, example 5. I'm going to say see text for method 1, and then I'm going to show you method 2. Did you say page 36? Page 36, yes. All right. 2 over x plus 3 minus 2 over a plus 3 divided by x minus a. The reason that I like method 2 better than method 1 is with a little bit of practice, you can start skipping some steps on method 2 and you get to the answer more quickly. As long as you're not skipping steps, the 2 methods are about the same. But it's easier for me to skip steps using this method than this method. What's the LCD of the baby fractions?
X plus 3 times a plus 3.
X plus 3 times a plus 3. I'm going to multiply every term by that. Here's the first term times the LCD. Here's the second term times the LCD. And here's the denominator times the LCD. When I'm multiplying a fraction times a whole expression, I put the whole expression over 1 so that I can cross cancel.
Yeah, but won't the fractions be not the same?
I could put in a middle step there and help you see why they are the same. If I multiply this times x plus 3 times Yeah, this is gonna get ugly because I didn't leave myself room to write that step. I'm write it this way. Ugh. I'm gonna hate how this looks on video because that's not my style. But actually, I multiplied the whole original problem by LCD over itself. And then I distributed the LCD times both terms in the numerator. So I'm going ugly times this one, ugly times that one, ugly times that one. Now, if I had to write that step in to do method 2, then this wouldn't be time saving. But I'm going to show you how it ends up that I can do that without having to write down that big ugly step. When I cancel my fractions in the first term, all that's left of the first term is 2 times a plus 3. When I cancel the common factor in my second term, all that's left is minus 2 times x plus 3. Nothing cancels in the denominator. And now it's just a matter of cleaning up the numerator. Typo.
There's nothing you can do with the bottom part, it just stays like that.
The reason that I've left the bottom in factored form is I'm trying to figure out if I can simplify that fraction. And I know the only way to simplify a fraction is if I can cancel a common factor. So I would leave that in factored form so that I can see if I have a common factor with the numerator.
Isn't one of those supposed to be a plus 3? Bottom.
Yes, thank you. And is that what you're going to say, Samantha? Dang it. I'm really regretting doing this problem, and I'll tell you why in just a minute. Samantha, what were you going to ask? If you factored out 2, what would that leave you in the numerator? A minus x. And is a minus x the same thing as x minus a? Could we just cancel? No, subtract. Order matters when you subtract. So you were very, very close, Samantha, but is there something else I could factor out in the numerator so that I would be left with an x minus a? Negative 2. If I want to change the order of subtraction, I factor out a negative. So if I factored out a negative 2, that would leave me negative a plus x, or I could just write it as x minus a. And if you need to convince yourself that that's equivalent to the line above it, just redistribute that negative 2, and sure enough, you get a negative 2x and a positive 2a.
And then does the x minus a cancel out?
Yes, absolutely. Now, let me tell you why I painfully regret having started this problem. Sometimes when there's more than one way to do a problem, One method will be easier on some problems and a different method will be easier on other problems. 99% of the time, I like method 2 better. Now that I've done method 2 on this problem, I'm looking in the book going, whoa, method 1 was easier on this one. And it didn't take them as long to do the solution using method 1 as it did me to do method 2. So as painful, and it's painful, time consuming as the experience was to do that using a method, a second method, sometimes you're going to start down a road in pre-calculus and you're going to realize there was an easier way to do that, but being as I've come this far, I'm just going to finish it this way. And you'll see me do that too. I don't always know the easiest method to use. Have I done something else knuckleheaded?
We've got -2.
They have the negative, I'm glad you saw that. They have the negative out in front of the fraction.
So that makes the x plus 3 and a plus 3 -2.
No, let me ask you this from basic math. If I have a negative out in front of a half, where did I write that? Right here. Is that the same as that? Yes, those are both -0.5. Is it the same as that? All three of those are -0.5. This is not normally the way we write a negative fraction, but all three of them are -0.5, so they're the same. Is that the same? That's +0.5. So the answer to your question is when you have a negative in front of a fraction, you can put it in the numerator or the denominator, but not both. Because if you put it in both, it changes the whole fraction to positive. With that in mind, you can see how their answer would be the same as our answer. You just put the negative in the numerator. All right, I feel bad that took so long. I was trying to show you this method is easier, and it turns out for this problem, this method is not easier. But we will continue to simplify complex fractions, and I think I can convince you that this method works really well on most problems. All right, so number 52 is the example that I typed for our complex fraction, only I don't even see why that's a complex fraction. Why do I have that one as my example of a complex fraction if complex fraction means little fractions within a big fraction? Negative exponents tells me that all four of those terms could be written as baby fractions. That y to the -2 is 1 over y squared, and x to the -2 is 1 over x squared. My method 2 is going to work really well on this one. And Samantha, it's also going to help you see why this is legal. I'm going to multiply the whole fraction by the LCD over itself, which is the only legal thing I can do to a fraction, multiply by the LCD over itself, and then I'm going to distribute that to all four terms.
It's just the top.
When I distribute it to all four terms, I'm going to put the LCD over 1. Oh shoot, you can't, I didn't see what I was writing that whole time. I'm going to give you a second to catch up in writing so that you can hear what I'm saying next. Look up when you finish writing down everything on the board so that I can tell when everybody's good to listen. All right. Can you see that what I have done is legal because all I did was multiply all 4 terms by the LCD. There's the original problem not highlighted and then each term multiplied by the LCD. Is that okay? All opposed? The reason I do that is so that I can cancel out the common factors. My next step is not a complex fraction. What's left of that numerator after I cancel out all the baby fractions? With a minus in the middle. X squared minus y squared. What's left of the denominator after I cancel out all the baby fractions? X squared plus y squared. Go back, simplify further. Can I factor the x squared minus y squared? It's the difference of 2 squares. Can I factor the x squared plus y squared? It's the sum of 2 squares. If you try x plus y times x plus y, you'll get a middle term. You can't factor the sum of 2 squares. You can only factor the difference of 2 squares. So yes, the numerator would factor, and it would be okay if I factored it. I don't have to factor it because I can see that nothing's going to cancel in the denominator anyway. So there's 2 things that would be okay for your answer, either that or factor the numerator, but the denominator won't factor.
You would take that as an.
Yes, that's absolutely fine. That's probably how it's written in the back of the book. Let me show you now why I think that this method, the other method, you get a common denominator, subtract those, get a common denominator, add those, and then say single fraction divided by single fraction, and that would be okay. But after a little bit of practice, I don't have to write this step anymore. I can look at the original of this, I can look at this and say, if I multiply by the LCD, the y squares would cancel and all that's left is x squared. If I multiply that times the LCD, the x squares would cancel and all I'm left with is y squared. Here, all I'd be left with is x squared. Here, all I'd be left with is y squared. So when you practice and you get to the point where you don't have to write this down, you can go directly to that, it's faster. But technically, I don't care which method you use as long as you can do it. If I can show you a shortcut that might be helpful to you in calculus, then I'm going to show you that shortcut and you just try it and see if you can do it. All right, that was simplifying complex fractions. Sometimes in college or in calculus, we need to rationalize the denominator. Sometimes we actually rationalize the numerator. We've never done that before, but it would work the same way. If you wanted to rationalize the denominator of a radical expression, let's say you had 2 over square root of x minus 2, what could you multiply that denominator by to rationalize it? Rationalize means get the radical out of the denominator. Well, that wouldn't work because, I mean, it's a good thing to try, but if we try that, then that will be rationalized. That would just be x, but this would still have a radical. So it's going to take something other than just square root of x.
square root of x times 2 in parentheses and multiply that. So
Times square root of x times 2, is that what you mean? Well, so that would rationalize this part, but this part would still be 4 square root of x. I'd still have a radical in the denominator. So we're just trying things, trying to figure out what would work here, and we haven't hit upon it yet. Somebody think of anything else we could try? Somebody usually says, well, let's just multiply by the whole thing. Let's multiply by the whole square root of x minus 2. And I say, okay, we'll try that. Would this be rational when I multiplied? Square root of x times square root of x is, y'all are scaring me unless somebody answers. Square root of x times square root of x is x. And square root of x squared, which is just x. Outer, I'd have negative 2 square root of x. Inner, I'd have negative 2 square root of x. When I combine those, I would still have a radical. I'd have negative 4. Oh, so what, that doesn't work because we get a middle term, right? And Samantha just said, oh, I know how to make the middle term go away. If that was a plus, the outer and the inner would cancel. Just be sure whatever you multiply the denominator by, you multiply the numerator by the same thing. That is what would rationalize that denominator. Because first would just give us x, outer and inner would cancel, last would just give us negative 4.
Yeah, but then you would have a radical.
And that's okay. We can't rationalize both the numerator and the denominator. We can rationalize one or the other. And if the directions say rationalize the denominator, it's okay if a radical ends up in the numerator.
So what was your final answer?
Well, I just realized this is not showing up on the video. Your numerator would end up being 2 times square root of x plus 2. The denominator would end up being just x, outer and inner cancel, and then minus 4.
When you say outer and inner cancel, what do you mean by that?
When you multiply a binomial times a binomial by full, you multiply the first and the outer and the inner and the last. The outer and inner give you 0. All right. There's a word for the relationship between these two guys. Two binomials that are identical, but one has a plus and one has a minus.
So why isn't that x plus 4? If the middle cancels out of
Thank you. Keep doing that. When I do, I can do calculus, but I can't do basic math.
Wouldn't it be a minus 4? Because it's a negative 2 and a positive.
Maybe I'm glad that's not on video. That would be a minus 4. That would be a minus 4. Dang it. So far, I just want to start this video over. I've done a problem the hardest way possible, and I can't multiply positives times a negative. There is a word for the relationship between a plus b and a minus b. Whenever I fool a plus b times a minus b, two identical binomials, except for one has a plus, one has a minus, the outer and the inner are always going to give you 0. There's a word for that relationship. Do you remember what that word is? Starts with a C. It sounds kind of like the word for prison sex, but it has nothing to do with prison sex whatsoever. That's a conjugal, is it? This is very close. It's a... Now they're looking at me like I'm crazy now. conjugates of each other. Y'all forgot the word conjugate. But I bet you won't forget it again. Because now every time you see A plus B times A minus B, you're going to think of prison sets. Here's a sentence that you can use to pick up nerds at a party. To rationalize the denominator of a radical expression, you multiply both numerator and the denominator by the conjugate of the denominator. Say that to somebody with a pocket protector and they're going home with you. So let's apply that to 62, and then we'll go back to 60, which I just realized we skipped. 62 says rationalize the denominator. That means get the radical out of the denominator. I may end up with it in the numerator, but at least I got it out of the denominator, and that's what the directions say. So here's that sentence again. To rationalize the denominator of a radical rational expression, multiply both the numerator and the denominator by the conjugate of the denominator. So what's the conjugate of that denominator?
You just change the minus to the plus.
2 square root of x plus square root of y. And that's legal because the thing I'm multiplying that original fraction by is just what? Anything divided by itself is just 1. I'm just multiplying a fraction by 1. All right. I could FOIL that numerator out. That certainly would be legal. Since my goal is going to be to cancel common factors, I'm going to choose to leave that factored rather than multiplying it out. You'll see why in just a minute. There's the numerator multiplied by the conjugate, but not FOILed out, just left in parentheses. Help me multiply this denominator. 2 square root of x times 2 square root of x would be what? 4x. 2 times 2 is 4. Square root of x times square root of x is x. Outer would be ugly, positive 2 square root of xy. Inner would be negative 2 square root of xy. So again, those cancel. Those give me 0. That's why I multiplied by the conjugate, so the outer and the inner would give me 0. Last is going to be minus what? Minus what? I have rationalized the denominator. I did what the directions said. But good math folks are always going to look at a rational expression and say, is there anything that I can factor in such a way I'd have a common factor that would cancel? Numerator has a difference of 2 squares. If I factored it, I'd have a common factor to cancel. So I'm going to go ahead and factor that difference of 2 squares. So that I can cancel a common factor. And here's what's left. In the back of the book, 99 times out of 100, they're going to leave that in factored form instead of spoiling it out now, because in calculus, we're going to have ugly expressions, and we're going to simplify them as much as possible, and then we're going to set them equal to 0 for a reason we'll talk about when we get there. That's easier to solve if we leave it in factored form than if we multiplied it out. If we multiplied it out, first thing we'd have to do is turn around and refactor it. So just leave your answer in factored form. All right. I really, really, really want to get to number 76. I think you probably need to see 60 though. So we're going to do 60 and we're going to see if we can get those other 4 done real quickly, and then I'll tell you where to stop in the homework. Number 60. If we use method 2 is multiply both numerator and denominator by the LCD. Your second step doesn't have fractions in it anymore. What is the LCD of those 2 baby fractions?
X times X plus 8.
And I'm so glad you said that, because if you had only said X plus H, I'm going to fix that in a minute, but if you had only said X plus H, I would have said, when you multiply X plus H times this, will it be legal to cancel the X's? No, that X is a term, you couldn't cancel them, so that can't be the whole LCD. The LCD has to have both the X and the X plus H. Good job on that. X times X plus H. And we're going to try to skip that middle step. We're going to say when we multiply that LCD times this first term, what cancels? X plus H, and what are you left with? Just X. When you multiply this times the first term, all you're left with is X. When you multiply this LCD times the second term, what's left? The X plus H. And notice that I had to keep the X plus H in parentheses, because in a minute I'm going to have to distribute that negative completely. That negative has to be distributed completely, so I have it in parentheses for the time being. The denominator is just going to have the H, the X, and the X plus H. I don't want to multiply it because my goal is seeing if there's any common factors. Clean up the numerator and see what happens. X minus X is 0. Distribute that negative completely and you have negative H.
So those 2 X's cancel out before you get to the negative H, so X minus X.
The step I skipped was this, X minus H, when I distribute that negative completely, and yes, X minus X is 0. What's the only other thing I can do? Is it legal to cancel the H's? What's holding the H onto this other stuff? Is it added or is it multiplied? It's multiplied. That makes it a factor, and it's legal to cancel common factors. You couldn't cancel these 2 H's because this H is a term. It's added to something. But as long as that H is multiplied, I can cancel them, and what's left in the numerator?
Even when it's a negative?
As long as you leave a negative 1. We're just saying H goes into negative H, negative 1 times. All right. Number 7. Read the directions here. Always read the directions. Express as a sum of terms of the form a times x to the r, where r is a rational number. I'm going to have to read that again just to figure out what it's saying. A sum of terms, each term is a number times x to a power, where the x to the power has to be a rational number. I don't really know how to apply that to number 70. I'm thinking, how am I going to get that to be? Right now it's a quotient. It's something divided by something else. That's a quotient. How could I get it, instead of being a quotient, how could I get it to be 3 separate terms? You can divide all 3 terms in the numerator by the denominator. Now, one other thing, just so I don't have to add another step here, how could I write square root of x with an exponent rather than a radical? X to the 1/2. So I'm just going to divide all 3 terms by x to the 1/2. Is that legal? Is that equivalent to what's on the line beside it? Yeah, I just wrote it a different way. Now I can use the quotient rule to simplify each term. Quotient rule says subtract the bottom exponent from the top exponent. So in that first term, 2 minus 1/2 is 3/2. You can't do fractions in your head, punch it on the calculator. That's 4/2 minus 1/2 is 3/2. Second term, x to the first divided by x to the 1/2, 1 minus 1/2 is 1/2. Third term, how could I write that like the directions are saying? The directions said each term needs to be just a constant times x to a power. How can I write that as 6 times x to a power? What would the power be?
Negative 6x to the half.
If I wrote 6x to the 1/2, does this mean the same thing as this? No, but what would mean the same thing as this? 6x to the 0 would be just 6. X to 0 is just 1. What causes a variable to be in the denominator? 6x to the negative 1/2. Now do I have exactly what the directions said? Do I have a sum of terms? Do I have 3 terms? Each term is a number times x to a power, where the power is a rational number. That's what's still making you frown about that.
Just where you went to get there, that's all.
Are you okay with the first term or not yet?
I understand the terms, I'm just trying to see exactly how I got there. I'll talk to somebody to do this.
Mallory's there. Were you okay with that first line? Breaking that up into 3 baby fractions. Was that okay?
Yes.
Okay. So all I did after that was I could have given you this problem the first night for homework. I could have said when you divide 2 expressions, subtract the bottom exponent from the top exponent. 2 minus 1/2 is 1.5.
Right.
1 minus 1/2 is positive 1/2.
Okay.
Only way to write that, in the way that the directions said to write it, is 6x to the negative 1/2. This is the same as that, because the negative exponent throws that right back in the denominator. Okay, good. All right. Number 72, we don't have time to do it. I'm gonna say full and then break into separate fractions. It only has one step more than the problem above it. This numerator, once you fold it out, you'll break it into 4 separate fractions and do the same thing you did on number 70. All right, you got to do these two so that we can get there in the homework. 74 says express as a quotient. It's doing the exact reverse of what we were doing in 70 and 72. 70 and 72, we had a quotient and we broke it into terms. 74 and 76, we have terms. We want to write it as a quotient. So we're just going the opposite direction. If I told you to factor this, what would you factor out? X squared, and how do you decide that? How do you know which one to factor out? You can only take out the lowest exponent because you can't take an x cubed from a guy that only has x squared. So the rule for factoring is you can only factor out the lowest exponent. Number 74, what's the lowest exponent? The exponent of this x is 1. The exponent of that x is -5. Which one's the lowest? -5 is lower than 1. So just like this other problem, I don't know how it's going to work, but I'm going to factor out the lowest exponent, and I'm going to figure out what that leaves me inside parentheses. I've never factored out something with a negative exponent before. But I know what factoring means. Factoring means take out the GCF, and whatever I'm left with in parentheses has to multiply back times that to give me the original problem. So what can I put right here that would multiply times that to give me back the x to the -5? Just a 1. Ooh, so far so good. And then I'm going to have a minus because I have a minus right here. But what in the world could I put in this blank that if I multiplied it by x to the -5, it would give me back that x to the first? Squint really hard. If I had x to the something right here, and I was checking my answer, what would I do with those two exponents? I'd add them. So really I'm asking, what do you add to -5 that would give you back that 1? -5 plus 5 would give you 1? -5 plus 6 would give you 1. And I'm telling you, you're going to feel shaky about this the first time you do it. But the great thing about factoring is it's checkable. Break and pencil. If that doesn't multiply back together to give us what we started with, we need to erase it and start over. But it does. That gives us x to the -5. That gives us x to the first. That's what we started with. We still don't have a quotient except for, how can I write that as a quotient? One more step. What about that x to the negative exponent? What could I do with it?
Minus x over, or x to 6 over, over x to the
Beautiful. That's my quotient. And I can work backwards from here to here, just like I did in number 70 and 72. I could break that into 2 fractions, simplify each fraction, and that's exactly what I would start with. All right, last one. What's the lowest exponent on number 76? Lowest exponent is x to the -2/3. If I don't get anything else right, I know that's the GCF because it's the lowest exponent. What would I have to multiply times x to the -2/3 to get back this x to the -2/3? just 1. And then I know I'm gonna have plus x to the something. I just need to figure out what that something is, and it's the hard part. If we had plenty of time, I'd let you sit here and squint a few minutes until God just whispered the answer. You don't have time to wait on God to whisper the answer right now. So I'm going to tell you the fast way of finding what goes in that blank. If this plus this has to give you this, then this minus that will give you this. Just take the original exponent and subtract the exponent you're factoring out. 7/3 minus -2/3 is the same thing as 7/3 plus 2/3, which is 9. Which is 7/3 plus 2/3, 9/3, which is 3.
So it's x to the third.
Yes, x to the third is what's left inside the parentheses. The x to the -2/3 you can put in the denominator. So, once again, you didn't get quite to where I would have liked to have gotten, but that's okay. The homework on page 39, you did through 47. I'm going to say 49, 51. I don't want you to worry about 53. It's number 49 to 53. And then 61 to 71.
All of them are.
Just the odds of everything I've listed. Odds only, so you can check your answer in the back of the book. Miss Samantha, I will email. Hey, I will put this in a minute. Look up just a second. I'll put this, I'm going to email Samantha and I'll tell her this, but I just looked down and number 63 is horrible. I don't care about it.
Don't do 63.
Yeah, I don't want you to worry about 63.
So, what did you say?
My knee just, my knee.
Oh, you
I'm
get it
growing
out?
old. It did, it just went, yeah, yes, sir.
Maybe we
I'm
It's
so,
been 5 years since I'm over 40.
and how did you, was that college algebra? And how did you do it in it when you were
I
there?
have an A, it's just my thing. I've always said A's in my class, my thing is just like, it's not the math, it's knowing what to do where.
That's the math.
Yeah.
Yeah.
That's not having trouble.
Yeah,
Because like I can do it if, like, I could just have to get that 1 7-minute clicks and it's done. It's quick, it's just like
Right.
finding out like, I think I need to review like stuff.
That is a good thing. That's a good thing. Let me say one thing and then I'll tell you my recommendation there. The levels of understanding in math, the first level is if you give me an example, I can do a problem just like it. And that's what it sounds like you're saying. You give me an example, I can do something like it. The next level of understanding is you can give me a problem without example and I can figure out what to do with it. And that's where not only you are stuck, but a whole lot of people get stuck. They can copy examples, but just looking at a problem and knowing what to do takes lots and lots of practice. And you'll get there. You'll get there. I have a
And
great,
understanding the direction on certain problems because I don't do that.
Yes.
I guess I'll figure out the terms.
yes. So the answer to your question is, my daughter Mallory is the only tutor in the Learning Center who can do college algebra and above. So she's the one I recommend, and she's in there until 2, Monday through Thursday. So the very best thing you could do if it fits your schedule is go right after class. Yeah, go right after class and say, I'm just going to sit here and try my homework, and if I get stuck, I'll wave at you. But try it on your own before you wave, and then don't be surprised if she has to say, let me see an example like that, because she hasn't done it in 5 years either.
Yeah.
She's sitting in my calculus class to bring it all back, but if you just gave her a problem like that, she's gonna go, whoa, I forgot that.
Yeah.
She'll look at an example and remember it, but maybe the three of you working together would be a great thing. The two of you and Mallory?
Yeah, okay, I'm cool to work with anybody. Like I said, I just think like, yeah, you need to remember stuff, because I know how to do it, it's just like knowing what to do where.
Yeah.
And like what answer you're looking for, when like,
I
because
understand.
sometimes I'll have the answer and like try to keep going.
Yeah, yeah,
And it's
I
like, well,
understand.
if I'm-
Another great thing about y'all working together is you said I need to learn the terms. When you're working with somebody and you're explaining some stuff to Scott and Scott's explaining stuff to you, it forces you to use those terms.
Okay.
And you stop saying X with a little check marky thing. You know, square root.
Yeah, well, I'll be in there Monday if you want to do that.
Okay, not today? Can't.
No, I have work
Can't.
today, yeah.
Okay.
I work, Monday will be my only day off, like every other day, Monday through Thursday.
Ooh,
Is a
so you're only gonna be
13-hour day for me
So you're only gonna be able to get help once a week?
on Mondays, yeah.
That kind of concerns me. I don't know what you can do about it, but my gut says you need help more than 1 day a week.
I can stay as long as I need to for that one day. So because like, I can get from 9:50 until 5 at night, I'm free on Mondays. But other than that, I have work, so there's no way for me to get
There's
out.
a limit to how much you can absorb in 1 day. But do the best you can. Your job is one that you couldn't say, hey, could I come in an hour later? No. I mean, some jobs you can, but some jobs you can't. Okay.
But,
Okay.
all right,
right.
thank you.
And you said the other days you start work at what time?
At 10.
Okay, so you go straight
yeah,
from
I
here.
go straight there, yeah.
Okay.
The latest,
Never mind.
the latest I can be there is 10:20, so
All right. See you.
thank you.
Okay, we're going to talk about rational expression. Scott, what can I do for you? Pray? You want me to
Yeah,
pray?
well, you can do that, yeah, there's no doubt.
You'll be all right.
I apologize for my tardiness.
You are so fine.
I
I don't.
have some things that have to be done. My dad is Alzheimer's, or not Alzheimer's, I'm sorry, my mom was Alzheimer's,